Welcome to math classes. Today we'll try the trigonometric series function proof and derivation. Okay, I'll give you two of them, very easy. Okay, I always say that best way of remembering a formula is to try the proof. Okay, so you try the proof yourself and then you will remember the formula easily. Okay, so yeah, first one we'll try is this one, sine a plus sine a plus x, sine a plus 2x up to sine a plus n minus 1x equal to, which we can also write it as sigma of sine a plus kx, k runs from 0 to n minus 1, is nothing but sine nx by 2 divided by sine x by 2 sine of a plus n minus 1 divided by 2 into x. Okay, so carefully see what is this actually. Okay, everything is sine here. The angle is in arithmetic progression. Okay, angle is in arithmetic progression. Number of terms are n. Okay, n number of terms. So this is the important thing to note. Okay, so let's see. Let's multiply this with and divide with 2 sine x by 2. Okay, 2 sine x by 2. Why I am doing it? I need half of the difference, basically difference angle. Okay, so 1 by 2 sine x by 2, and each term is multiplied with 2 sine a. Okay, multiplied with 2 sine x by 2. Okay, so sine a will become 2 sine a sine x by 2. Next, sine 2 sine a plus x into sine x by 2 up to 2 sine a plus n minus 1 x. Sorry, yeah, n minus 1 x into sine x by 2. Okay, so now we know that this is in the form of 2 sine a sine b. Correct? 2 sine a sine b, we know the formula is cos a minus b minus cos a plus b. Okay, we also use this one next. Okay, so 2 sin a sin b, we can rewrite this each term into cos a minus b minus cos a plus b. Okay, so carefully write it. 1 by 2 to the power of 1 by 2 sin x by 2 is there as before. Now this will become cos a minus b, which is nothing but cos a minus x by 2 minus cos a plus x by 2. Okay, plus second one cos, okay, a plus x minus x by 2, which is nothing but a plus x by 2 minus cos a plus 3x by 2. Okay, similarly you write everything, and the last term will be cos of a plus n minus 3 by 2x minus cos of a plus n minus 1 by 2x. Okay, now if you see, all these terms gets cancelled, second and this one, so all the terms gets cancelled, only we will be left with first and last. Okay, so the first and last is 1 by 2 into sine x by 2. Then first one is cos of a minus x by 2 minus cos of a plus n minus 1 by 2 x. Okay, now I am applying this cos a minus cos b. Okay, which is nothing but minus 2 sine a plus b by 2 sine a minus b by 2. Okay, so 1 by 2 sine x by 2 minus of 2 sine a plus b by 2, right? So if I add these two, a plus b by 2, 2a by 2, which is a, minus x by 2 plus n minus x by 2, right? Nx minus x by 2. So I will get basically n minus 1 uh, divided by 2x. Okay, a plus n minus 1 divided by 2x. Okay, and then sine of a minus b by 2. In this case, a gets cancelled and I will be left with only minus nx by 2. Okay, so sine of minus nx by 2 is minus sin x by 2. So this minus and this minus gets cancelled. Okay, so I will be finally left with sine nx by 2 into sine of a plus n minus 1 by 2x divided by sine x by 2. This is nothing but the RHS. This is the proof derivation of this one, right? So other way of doing this one is, if you know the formula, you want to see how to prove it. Of course, mathematical induction is there. You can try that. So let's see, using mathematical induction also you can prove it. Okay, you have the formula already, and let's say mathematical induction, first we will take n equal to 1, that is one term. If it is first term, LHS is sin a, RHS will become sin x by 2 by sin x by 2, because n is equal to 1, right, into sin a, which is nothing but sin a. So for n equal to 1 we proved it, and we will assume that it is sorry, okay, we will assume that it is true for n equal to k. Okay, which is n number of terms or k number of terms. Okay, so then it will become sigma k equal to 0 to k minus 1. This is k terms. Sine of a plus kx equal to sine kx by 2 sine a plus k minus 1 by 2 x divided by sine x by 2. Okay, this is what I wrote it here. Okay, so this we are assuming it's correct. All right, now let's prove it for n equal to k plus 1. Okay, for n equal to k plus 1, okay, it will become sigma k equal to 0 to k. This is k plus 1 terms. okay, which is nothing but sine of a plus kx, which is equal to sine of, okay, this is up to k minus k terms, okay, right? This is up to k terms, sum up to k terms plus sine a plus kx. This is the last term which I am adding, okay, the n equal to k plus 1 term, okay, which I am adding it here. Now, what we will do is, okay, this is how it is. If I multiply this into numerator and denominator form, basically common numerator and common denominator. Okay, this is what it is. Now I will apply sin A into sin B equal to half cos A minus B minus cos A plus B. Okay, so because you have sin A, sin B, correct? Sin A, sin B. I will apply sin A into sin B formula here. So if I carefully do it, what it will become is half is common, so half into cos. Okay, A minus B nothing but I will get a minus half x. I will get actually half x minus a, but cos both are same. Cos minus a is cos a. So cos a minus half x minus cos a plus k minus 1 by 2 x. Okay, and this term will become cos of a minus k minus half x minus cos of a plus k half x. Okay, so now if you see this term, second term and third terms are same with negative opposite signs. Correct? So I will remove them. Now and I'll apply cos A minus cos B equal to minus 2 sin A plus B by 2. Sorry, this is only for angle. A plus B by 2 angle division is, and sin A minus B by 2. Okay. So if I apply this one on, what are the terms I have? Cos this one and this one. Okay. If I apply these two, it will become minus 2 sin A plus K by 2x into sin minus K plus 1 by 2x. Okay, which is nothing but on the RHS side, if I substitute K equal to K plus 1, this is what I'll get exactly, right? So this means for K plus 1 also I proved it. So by mathematical induction, I can say that this formula is correct. Okay. So this is one formula, and second one we know cos A plus X exactly similar. So you can try the proof exactly same way. Okay. Uh, just do it yourself. And the third series formula is this one. This is very, very simple to prove. Okay. You just multiply and divide with 2 to the power of n sin a. Why I am doing it? Okay, so if I do this 2 to the power of n, you forget sin a cos a I have, which I can write it in sin 2a form. Sin 2a cos 2a, again I will write it in sin 4a. So it will keep on going like this, right? So and 2 to the power of n, because I have n terms here, so I added 2 to the power of n. For each sin a cos a, I need 1 2. Correct? So finally this will become nothing but, okay, this if I replace, this will become sine 2 to the power of n a. The last one will be 2 sine 2 to the power of n minus 1 a into cos 2 to the power of n minus 1 a, which will become again 2 times, right, of 2 to the power of n minus 1, which is nothing but 2 to the power of n. So sine of 2 to the power of n by a divided by 2 to the power of n sine a. This is nothing but RHS. This is the proof. Okay. Hope you understand these proofs of series trigonometric series functions. They are very useful. I think uh, every year you are getting a question on these formulae. Very simple, straightforward substitutions most of the time. Okay. Thank you. Yeah. Keep doing maths till then. Thank you.